Hello viewers, this is Wagda Ronald taking you through the tutorial for A-Level Applied Mathematics. And this tutorial we're going to look at the topic of motion on inclined plane involving an external force. So this topic is under mechanics and suitable for students in senior 5 and senior 6 offering principal mathematics as part of their combination. Now these are the very questions I left in the previous video, and I believe by now you are ready to try them out and ready to mark yourself and check your progress. So we shall start with question 1. Now question 1 came from UNEB 1997, paper 2, question 14, and it says a particle of mass 0.5 kilograms is released from rest and slides down a rough plane inclined at 30 degrees to the horizontal. It takes 6 seconds to go 3 meters. So when S is 3 and T is 6. Find the coefficient of friction between the particle and the plane correct to 2 decimal places. So note here they have given us the accuracy, so at the end you have to remember to round off to 2 decimal places. Then part B, what minimum horizontal force? Minimum horizontal force. Remember, when you talk about minimum, it implies the particle is just about to slide downwards. So what minimum horizontal force is needed to prevent the particle from moving? So you start with the Roman 1 from the second equation of motion. S we know that is 3 and U is 0 because it started from rest. A is unknown, but T is known as 6 seconds. So when you substitute, we have only A, which is an unknown. Therefore, we can simplify and make A the subject, which will be 1/6 meters per second squared. So now that I've got acceleration, we can come and draw our diagram. So the particle is on an incline of 30 degrees to the horizontal as told in the question. Now we know that the weight will now be 0.5 g because the mass was 0.5 kilograms. Then the component of this weight, a part of the plane will be 0.5 g sine 30, and the component perpendicular to the plane will be 0.5 g cos 30 degrees. Then the normal reaction will be capital R. So in the question they told us that the particle slides down a rough plane, therefore the acceleration will be downwards and it will be 1/6 meters per second squared. Then because it is rough, there has to be friction to oppose motion. So before we go to the next slide, let's see marks for this slide. So M1 was for substitution, the second equation of motion, B1 was for you to get the acceleration, and B1 for the correct force diagram drawn using a ruler. Then we shall continue. Remember they asked for coefficient of friction between the particle and the plane. So we are going to resolve perpendicular to the plane. So when you go back to our diagram, resolving perpendicular to the plane, it implies that R will be equal to 0.5 g cos 30 degrees, and parallel to the plane, it implies that this will be equal to that. So you come and say that perpendicular to the plane, R is equal to 0.5 g cos 30, which will be equal to 4.2435 newtons. So when you substitute for g, which has 9.8, you realize you'll come up with 4.2435 newtons. What about when I resolve power to the plane? The resultant force will be 0.5 g sine 30 minus mu r, which will be equal to ma, but our m is 0.5. So when I substitute for g and for r, I'll come up with this expression, and realize that I only have one unknown, which is mu. So the next task is to look for making mu the subject. So when I simplify, I'll come up with that, and when I make mu the subject is 0.56. Remember, they told us to write our final answer into 2 decimal places, so at the end you have to round off to 2 decimal places. So before we go to the next part, let's see how much can be awarded for this slide. So B1 for getting normal reaction, M1 for resolving, M1 for substitution, M1 for simplifying, and A1 for the output corrected to decimal places. So now we shall go to Roman 2. So for Roman 2, they told us that what minimum horizontal force is needed to prevent the particle from moving. So we have to come and draw another sketch. So that's the particle. We shall put the weight as 0.5 g, the component of weight parallel to the plane, which is 0.5 g sine 30, and the component of weight perpendicular, which is 0.5 g cos 30 degrees. Then the normal reaction R and the horizontal force capital F. Then the component of that horizontal force parallel to the plane will be F cos 30 degrees, while that perpendicular to the plane will be F sine 30 degrees. Then the particle will be at the point of sliding downwards, so it will have zero acceleration. Therefore, and the friction will oppose motion, so it will be acting upwards along the line of greatest slope. Next is now to resolve perpendicular and parallel to the plane. So perpendicular to the plane, R will be equal to these two forces. So you shall come and write that. R is equal to 0.5 g cos 30 plus F sine 30. What about resolving parallel to the plane? So parallel to the plane, this force will be equal to the sum of these two forces. So you shall come and write that 0.5 g sine 30 is equal to F cos 30 plus mu R. Now R is given, R is here, and mu we already got it in Roman 1. So we shall come and substitute for mu and for R. Then G is 9.8. So when I simplify that, I'll come up with that step. So what I've done, 0.56 multiplied by this will give me that, and 0.56 times this will give me that. Then this 0.5 times 9.8 sine 30 will give me that. Now when I simplify, I come up with F being equal to 0.0642 newtons. So basically that's what they wanted. Now let's see how much can be awarded. So B1 for the correct force diagram, then this was supposed to be M1. So M1 for this right hand side resolving and also substituting for R. Then A1 for the output. Then we shall go to question 2, which came from UNEB 1991, paper 2, question 8, and says, a train of mass 300 tons is pulled from rest down an incline by an engine of tractive force of 120 kilonewtons. So tractive force means pulling force, upward force. The air resistance to the motion is 90 kilonewtons. Roman 1. If the train attains a speed of 63 kilometers per hour in 25 seconds, determine the slope of incline. So when t is 25, v will be 63 kilometers per hour and u will be 0. So I think let's start with Roman 1. So Roman 1, we know that we have to convert the mass to kilograms, so 300 tons to kilograms will be 300,000 kilograms. What about the kilometers per hour to meters per second? So 63 kilometers per hour will be equal to, so to convert the kilometers to meters will be multiplied by 1,000, and to convert the per hour to per second you'll divide by 3600. So 63 kilometers per hour is equal to 17.5 meters per second. So now that we know v and we know u and we know t, you can come and substitute. So v is 17.5, u is 0, and t is 25, so acceleration will be 0.7 7 meters per second squared. So now that we know acceleration, we can come and make our sketch. So the inclination, we don't know it, is what we are looking for, so it will be theta. So this is the mass, so we shall put there the weight, which will be 300,000 g. Then the component of this weight part of the plane will be 300,000 g sine theta. What about perpendicular to the plane? It will be 300 g cos theta. Then the normal reaction will be r. Then the resistance, the forward force was 120 kilonewtons, so 120 kilonewtons will be 120,000 newtons. But there was also resistance, so the resistance was 90 kilonewtons, which will be 90,000 newtons. Then the direction of motion is down the plane. So before we go to the next slide, let's see how mass can be awarded for this slide. So B1 will be for getting acceleration, another B1 for drawing the correct force diagram with a ruler. Now next is to resolve. So when I resolve, to resolve parallel to the plane, it implies that this sum of these two forces will be equal to this. That the resultant will be this, the sum of this minus the resistance, equal to MA. Then perpendicular, it will be R equal to 300 g cos theta. So parallel to the plane, we shall come up with 120,000 plus 300 g sine theta minus 90 kilonewtons. So this one gives the resultant force. So the resultant force is that in the direction of motion, equal to MA. So M is this and A is that. So when I simplify, I'll come up with this, and when I simplify further, I'll come up with that, and when I simplify further, I'll come up with sine theta equal to that, and when I make theta the subject, it will be 3.5101 degrees. So basically that was Roman 1. Now Roman 2 said, at that time, a tree which fell across the rails is sighted ahead and the driver immediately applies brakes. If the train stops after moving a further distance of 300 meters, determine the force exerted by the brakes. So first of all, you shall know that acceleration will be equal to, using the third equation of motion, we shall know that when it stops, it means that final velocity is 0, so we shall put 0 for v, and u was the velocity was moving with, which is 17.5. S is 300 meters, therefore acceleration will be negative 1.0208. Now before we go to the next slide, let's see how much can be awarded for this slide. So M1 for left hand side and M1 for right hand side. A1 for output, B1 for acceleration. Now that we know acceleration, we shall come and make our sketch. So we shall put there the weight, which is 300,000 g, then the component parallel to the plane, 300 g sine. Now we know the angle, so it will be sine 3.5101 degrees. Then the component perpendicular of the plane will be 300 g cos 3.5101 degrees. Normal reaction is R. So the resistance is this, which is 90 kilonewtons, which is 90,000 newtons. But remember, you also applied brakes, so the force due to the brakes, you let it be F1, and that is what they want. So the deceleration is also in that direction. I think we see the negative means it is decelerating. So now let's resolve parallel to the plane. So parallel to the plane, it implies that this minus these two must be equal to MA, where A is this. So we shall come here and write that 300,000 G sine 3.5101 degrees minus the sum of these two forces, which is 90,000 plus F1, is equal to MA, where M is 300,000 and A is negative 1.0208. So when I substitute for G, I'll come up with that and open brackets. So, and when I simplify further, I'll come up with that. And when I make F1 the subject, I'll come up with 396,239.99485 newtons. So basically, that's what they wanted for Roman 2, and now let's see how marks can be awarded. So M1 for the correct force diagram drawn using a ruler, M1 for left hand side, M1 for right hand side, and A1 for the output. So now we shall go to Roman 3, which says that if the brakes fail and the tree is carried along the rails at a constant speed of 25 kilometers per hour, what is the resistance to the motion of the train? So we are going to first draw our sketch diagram. So first of all, put there the weight, then the component of weight parallel to the plane, component of weight perpendicular to the plane, normal reaction capital R, the resistance to motion, the new braking force, which is F2, and the acceleration. Now acceleration, because the velocity is constant, means that acceleration will be 0. That's why I put here 0. Therefore, resolving parallel to the plane, we shall come up with that this force being equal to this, simply because acceleration is 0. So when I make F2 the subject, I'll come up with that, and when I simplify, I'll come up with F2 being equal to 89,999.99485 newtons. So basically that's what they wanted, so we shall say M1 for resolving and A1 for output. Now we shall go to question 3, which says that a particle of mass 2m rests on a rough plane inclined to the horizontal at an angle of arctan 3 mu, where mu is the coefficient of friction between the particle and the plane. The particle is acted upon by a force of P newtons. Part A, given that the force acts along the line of greatest slope, that means that it acts parallel to the plane, and that the particle is on the point of sliding up, you know that word, sliding up, show that the maximum force possible to maintain the particle in equilibrium is P max equal to 8 mu over square root of 1 plus 9 mu squared. So I think let's start with part A. So for part A, we are told that the inclination is arctan of 3 mu. So when I make 3 mu the subject, I'll come up with tan theta being equal to 3 mu. Then from there I'll come up with a triangle, because tan is equal to opposite over adjacent. Therefore, this is the same as 3 mu over 1. Therefore, opposite is 3 mu and adjacent is 1. Therefore, when I use Pythagoras theory, I'll come up with my hypotenuse as square root of 1 squared plus 3 mu squared. From there, I'll realize that sine theta will be equal to opposite over adjacent, which is 3 mu over square root of 1 plus 9 mu squared. What about cos theta? Cos theta will be adjacent over hypotenuse, which is 1 over square root of 1 plus 9 mu squared. So now that I know the inclination, I can now draw my diagram. So I'll start with the weight vertically downwards, which is 2 mg, because the mass was 2m, so the weight will be 2 mg. Component part of the force 2 mg sine theta. Component perpendicular to the plane to be 2 mg cos theta. The normal reaction will be R. So force which is parallel to the plane will be P max, and that is that, because it is acting upwards according to the question. Then the acceleration is also upwards. Remember, it said at the point of moving upwards, therefore acceleration is 0. Because moving upwards, friction will act downwards. Now before we go to the next slide, let's see how much can be awarded for this. So B1 was for you to get the sine and cosine expressions, then B1 for the first diagram drawn using a ruler. So now resolving perpendicular to the plane, when we go back to this first diagram, resolving perpendicular to the plane will be R being equal to 2 mg cos theta, while parallel to the plane will be these two forces equal to P max. So you are coming and say that R is equal to 2 mg cos theta, but remember cos theta was 1 over square root of 1 plus 9 mu squared, which so when I multiply 1 times square root of 1 times 9 mu squared by 2 mg, I'll come up with 2 mg over square root of 1 plus 9 mu squared. What about parallel to the plane? So parallel to the plane, I'll come up with P max being equal to 2 mg sine theta plus mu r. So when I substitute for sine theta and for r, sine theta I'll put there that, and r I'll put there that. So mu is there, and this 2 mg is there. When I simplify, I'll come up with this. So this mu with this will give me 2 mu mg, and this 2 mg by this 3 mu will give me 6 mu mg. Things realize that the denominators are the same, therefore I'll just add the numerator to come up with 8 mu mg over root of 1 plus 9 mu squared as required. So this was the required expression for part A, and now let's see how marks can be awarded. So B1 for you to resolve to get the normal reaction, and another M1 for resolving, M1 for substitution, B1 for simplifying to the required expression. Now we shall go to part B. Part B says that given that the force acts horizontally, know that word horizontally, in a vertical plane through a line of greatest slope, and that the particle is on the point of sliding down the plane, show that the minimum force required to maintain the particle in equilibrium is P mean equal to 4 mu mg over 1 plus 3 mu squared. So we shall have to first draw our sketch diagram. So that's the particle. We shall first put the weight, which is 2 mg, then the component part of the plane 2 mg sine theta. Component perpendicular to the plane will be 2 mg cos theta. Normal reaction is capital R, and the horizontal force is P mean. Now the component of this force part of the plane is P mean cos theta, and its component perpendicular to the plane is P mean sine theta. And the particle is at the point of moving downwards, that's why this acceleration is 0. Because at the point of moving downwards, friction will be moving upwards. Now we are going to resolve perpendicular to the plane. So perpendicular to the plane, we shall say R is equal to these two forces. So we shall come and write that. So when I substitute for cos theta and for sin theta, I'll come up with that. Now before we go to the next slide, let's first see marks for this slide. So B1 for correct force diagram drawn using a ruler, M1 for resolving, and M1 for substitution. Now next is to resolve parallel to the plane. So when I resolve parallel to the plane, it implies that these two forces will be equal to this, and that is because A is 0. So come and say that 2mg sine theta is equal to p mean cos theta plus nu r. So when I substitute for sine theta and for cos theta and for r, I'll come up with that expression. So this here, there is sine theta times this to give you that, and here cos theta and r mu r to give me that expression. So when I simplify, I think realize that all of them have the same denominator. So this and this will cancel to remain with 6 mu mg here, p mean here, 2 mu mg here, and 3 mu squared p mean here. Then from there I'll simplify further, because this p mean and this have a common factor, which is p mean. I'll pull it out to remain with 1 plus 3 mu squared. And when I make p mean the subject, I'll come up with 4 mu mg over 1 plus 3 mu squared as required. So basically that's what they wanted. Now let's see how much can be awarded. So M1 for resolving, M1 for substitution, B1 for simplifying to the required expression. So thank you for watching. Be reminded that the next video will be on motion of connected particles. Therefore, if you have not yet subscribed, please click on the subscribe button below this video so that you can be updated when the next video on connected particles has been uploaded. Otherwise, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.